Hi everyone, Mr. Patron, and in this video, I'm going to take some time to go through the answers to the titration practice questions that were set up for your most recent follow-up assignment. So it is the 6 questions that are at the end of that assignment. So I'm just going to go through the answers and how to go through them. Like I mentioned, this portion of the assignment was graded on completion and not accuracy. So you're not going to get penalized for the incorrect answers. I went through most answers, just a quick scope over, and they looked pretty solid. A couple of mistakes here and there, and a couple of consistent mistakes with some folks. And I'm just going to be here and clear those up. If you have any questions about any of the specific examples, feel free to reach back out with an email. All right, I'm going to share my screen and open up the document, and then I'm going to go over how we go through these. Okay, so this should look fairly familiar. Like I said, these are the titration practice questions from your follow-up assignment. So I'm going to go through them one by one. All right. So first one, it says, write a balanced equation for the neutralization reaction between sodium hydroxide and hydrochloric acid. And you're going to use this equation for questions 2 and 3. So first off, just a reminder, the neutralization reaction takes an acid and a base and produces water and a salt or an ionic compound. So we'll look at our acids and our bases. So sodium hydroxide is our base and hydrochloric acid is our acid. So we have HCl plus NaOH. Once again, HCl our acid, NaOH our base. So as had been gone over in class, a neutralization reaction is a double replacement reaction. So the cations, the positively charged ions here, are going to switch places. So in this case, that is H and Na. So these two are going to swap. So now sodium is going to be bonded to chlorine, NaCl, and then our final product is water. That water comes from the fact that now hydrogen is bonded to the hydroxide. So H and OH make H2O. So this is our neutralization reaction. Again, HCl, hydrochloric acid, plus sodium hydroxide yields sodium chloride and H2O. No difference on the order. You can put water first. The only thing to keep in mind is that for ionic compounds, and in general for all chemical formulas, the metal will always go first. So sodium and then chlorine, NaCl. Okay, so let's take a look at number 2. Number 2 says, if it takes 54 milliliters of 0.1 molar sodium hydroxide to neutralize 125 milliliters of an hydrochloric acid solution, what is the concentration of the HCl, the hydrochloric acid? So this is an example of a traditional titration question. And I'm going to put the formula up here that we'll use for reference. The formula for our titration calculations is MABA equals MBVB. Once again, M stands for molarity or concentration, V stands for volume, and then the A and B stand for acid and base respectively. So I'll write that in as well. So M is molarity, V is volume, and then A is acid, B is base. And that's consistently how you would work through something like this. So let's figure out what we have here. So we have 54 milliliters of 0.1 molar sodium hydroxide. So we have our volume and molarity of our base. And that is to neutralize 125 milliliters of the hydrochloric acid. So this is the volume of our acid. And then we are looking for the concentration, the molarity of this HCl. So once again, we'll pop our formula down here. So I'm just going to rewrite it. MABA equals MBVB. We are looking for our MA, so that is going to be our variable. we have the volume of our acid, that's 125 milliliters. Our base, we have the molarity, 0.1, and the volume of 54. So then we're just going to do the algebra to do this. So we would end up with MA times 125 is equal to 0.1 times 54. So that would end up looking like MA times 125 equals 0.1 times 54 is 5.4. So we will just divide both sides by 125. And then your molarity of acid is equal to 0.0432 molar. So that's how you do question 2. Okay. You can pause and rewind if you need to take another look at this one. But we'll take a look at number 3 now. Right. Number 3 is a very similar question, just using different numbers. So we're going to use our same formula, MAVA equals MB times VB. Now it says here, if it takes 25 milliliters of 0.05 molar HCl to neutralize 345 milliliters of NaOH, what is the concentration of the NaOH solution? So once again, we are looking for a concentration, but this time of the base. We're looking for the MB. We have everything else. So our MA we have is 0.05 times 25 milliliters. And that is equal to our MB times 345. So once again, we would just do the math here. So you would do 0.05 times 25. And I'm just going to pop that into a calculator, which would give you 6.25 equals MB times 345. So we would divide both sides by 345. So then 6.25 by 345. I made a mistake, I'm sorry. I knew something wasn't looking right. It should be 1.25, not 6.25. So we'll divide that by 345. And you should get a molarity of 0.0036. And that is for the NaOH. So once again, solving for MB in this case, 0.05 times 25 is 1.25, and then divide both sides by 345 to mathematically get your molarity of base here. All right, so these first two questions were pretty straightforward and followed the basic format of the titration formula. The next two, well, the next reaction and then the following two calculation questions have a slight difference. So I'm going to clear and then scroll down. So pause, rewind if you need to rewatch for these first two. But I'm going to scroll down and then change some stuff up. Okay. All right. So the next question says, write a balanced reaction for the neutralization reaction between calcium hydroxide, CaOH2, and nitric acid, HNO3. We're going to use the results of this equation for questions 5 and 6. So let's go through this. So our acid here is nitric acid, HNO3. It's a hydrogen ion with the nitrate ion bonded to it. And then it is reacting with calcium hydroxide. Now, what's different about this particular reaction is that calcium hydroxide is a polyprotic base. So it has two hydroxide ions. That makes it essentially doubly basic. So to account for that, we're going to have to switch a couple things around for our neutralization reaction and for our titration calculation formula. But let's finish up this equation first. So once again, our neutralization reaction makes two main products: water, so we're still going to have H2O, and then an ionic compound. So our reaction, of course, still undergoes this double replacement reaction. So calcium and hydrogen are going to switch places. So H bonding to the OH gives us our water. But now calcium is bonding to the nitrate ion. But something to note, calcium has a +2 charge, where the nitrate ion is -1. So to balance out that charge, for every one calcium ion, once again, we have calcium is +2 and nitrate is -1. For every one calcium, we're going to need 2 of these nitrate ions. So it would be something like this. And then this will fully balance the charges. So 1 calcium and 2 of these nitrates. And we rewrite this as CaNO3 2. The nitrate ion is in parentheses, and we put the 2 here to signify that this is double. If we didn't have the parentheses, it would be NO32. So think back to how we did polyatomic ions way back when. Okay. Now, along with fixing up this formula here, we actually do need to balance the equation. But we can do this pretty simply. So these neutralization reactions often are pretty easy to balance. We'll just need to look at the ions in our ionic compound. So as mentioned before, we need 2 nitrate ions in our ionic salt. And there's only 1 currently present in the acid. So we're going to double the acid. So put a 2 here. And then we also now have 2 H's and 2 hydroxides. Remember, each H and hydroxide makes a water. So if we have 2 of these, we'll end up with 2 waters. So this is our fully balanced neutralization reaction between calcium hydroxide and nitric acid. These are a little trickier, so feel free to rewind and rewatch this. But now we'll see how this applies for the titration calculations. And this is where we have a slight difference. So I'm gonna please scoop this over here. And make a little line. Okay. So our titration calculation, the original one, the one that's given on your reference tables, assumes that we have solely monoprotic acids and monoprotic bases. So 1H, 1OH. However, if you're dealing with a polyprotic acid or a polyprotic base, we'll have to adjust how we perform this calculation. So we're actually going to include the number of hydroxides or hydrogen ions in our acids and bases. So we're still working with the same base formula, but instead of strictly MAVA equals MBVB, we are going to be using number of acid times MAVA equals number of base times MBVB. So this number here represents how many hydrogen ions or hydroxide ions there are. And I'm going to add this in here as well. So number A equals number of H ions, and then number B equals number of OH ions. So this is dependent upon the chemical formulas for our acids and bases. So we'll take a look at how this is applied here. So number 5 says it takes 50 milliliters of 0.5 molar calcium hydroxide. So here we have our volume and molarity of base to completely neutralize 125 milliliters of HNO3. So we have our volume of acid. We want to know the concentration of the nitric acid solution. Okay. Once again, we're going to be using our titration formula, but it's going to be modified. So we have number A, MAVA equals number B, MBVB. Now, we should be familiar with the MAVA, MBVB part. Sorry, a lot of similar letter sounds. But the number of each ion is where we're going to have to fix things up. So for our acid, we're dealing with nitric acid, HNO3, and there's only one hydrogen ion. So that we're going to leave just as 1. And then we are still solving for our MA, but we have our volume of 125 milliliters. Now for our base, calcium hydroxide has 2 hydroxide ions. So we're going to use that to start off this side. So 2 is going to go there. Our molarity is 0.5, and our volume is 50 milliliters. So once again, we're just going to do the math to get this all taken care of. So our right side is going to be 2 times 0.5 times 50, which comes out to 50. And then our right side is going to be 1 times MA times 125, which is equal to 125 times MA. So I'll rewrite this on the side. So 125 times MA is equal to 50. Divide both sides by 50. I'm sorry, by 125. And you should get that your molarity of acid is equal to 0.4 molar. That was number 5. And then number 6. We're dealing with the same formula, but we want to know how many milliliters of 0.5 molar nitric acid is necessary to titrate 25 milliliters of 0.05 molar calcium hydroxide to the endpoint. So the endpoint just signifies when the titration is complete, when neutralization happens. So when the pH is at 7. So it's no different from the other questions in terms of what you're doing, just including this little piece of vocab. All right. So once again, we're dealing with our number A, MAVA equals number B, MBVB. So our acid, we have, once again, 1. We have our concentration this time, 0.50 molar. And we're looking for our volume. So VA is what we're solving for. That is equal to our base, once again, 2 for the 2 hydroxide ions. So that's what goes there. Our concentration is 0.05. And we had 25 milliliters of our calcium hydroxide. So just like before, we're going to do the math for this. 2 times 0.5 times 25. I said 0.5, I meant 0.05. Is equal to 2.5. And then 1 times 0.5 times VA is going to be 0.5 times VA. And then to solve, we would divide both sides by 0.5. Cross that out. And 2.5 divided by 0.5 is going to get you a volume of 5 milliliters. Okay. So this was just going through those 6 questions. Of course, feel free to rewatch if you got stuck or if you need another look at these, and reach out if you have any questions. All right, bye.